Hi students, welcome back to Physics for All by Dr. Reddy Babu YouTube channel. In today's session, I am going to explain you about quantum theory of electron, which is the second topic in the unit 4. To know about the equation of quantum theory of electron, which we have to recap about the classical theory of electron, which is very useful to hear. In the case of classical theory of electron, Drude and Lorentz explained about the conductivity of conductors or metals based on the assumption that electrons are moving like gas molecules, and they got one equation for the resistivity rho proportional to root of capital T only. But in practically rho proportional to T only. This indicates that classical theory unable to explain about the specific heat of conductors based on the assumption that electrons are not moving like gas molecules. So this is a failure theory. So to overcome the drawbacks of classical theory, Sommerfeld is another scientist came into picture. He discussed about the quantum theory and they derived about the equation for the conductivity. Okay, according to the Sommerfeld, now here spelling is wrongly printed. According to the Sommerfeld, they explained about the conductivity of conductors based on assumption that you can take any metal or you can take any conductor which contains Fermi sphere. He is assuming that it is known as Fermi sphere, also known as Fermi surface. Okay, so based on this Fermi sphere or Fermi surface, it contains a lot of electrons inside of this Fermi sphere. All the black color dots represents electrons which are inside the Fermi sphere. Okay, now according to the Sommerfeld, the electrons here, not all electrons are moving like, not all electrons are participating in the conductivity. The electrons which are closer to the Fermi sphere, these electrons only participate in the conductivity. Based on this assumption, they explained about the conductivity. Now, according to the assumption, let us consider a conductor and apply it to some electric field capital E. Now, according to this equation, F is equal to E into E, where small e is the charge of the electron and capital E is electric field applied to the conductor. Let us say this is equation number 1. Then coming to the Newton's second law, we know that F is equal to ma. It is second equation. Equate 1 and 2. E into E is equal to mass into acceleration. Now we know from the basics of mechanics, acceleration is defined as the rate of change of velocity is known as acceleration. A is equal to dv by dt. It is the fourth equation. Now here substitute fourth equation, third equation, E into E is equal to m into, in the place of acceleration I am using dv divided by dt. Now write equation for it like this. Send E to left hand side, it will converted into E by m is equal to dv by dt. Write equation for E by m into dt, and you can write this is equal to dv, equation number 5. Already we know that kinetic density J is equal to Ne into dV. It is the sixth equation. Now substitute dV, that is fifth equation, in the sixth equation. We can write kinetic density J is equal to Ne into the place of dV. I am using the fifth equation, that is Ne divided by m into dt. Now here E will becomes multiply here. Kinetic density J is equal to, what I will write here, N E square capital E dt divided by m. This is the equation for the conductivity. Now we know that conductivity of the conductor sigma is equal to J divided by E. Now in this expression substitute the J value, that is Ne square E dt by m. Now we can get sigma is equal to N E square capital E dt divided by m into E. In this expression capital E will cancel, sigma is equal to N E square dt divided by m. Now we can write equation for the resistivity rho is equal to 1 divided by sigma. Substitute sigma is equal to N E square dt by m. We can write rho is equal to 1 divided by N E square dt by m, and now we can return this equation in the form of rho is equal to m divided by N E square dt. this equation is similar to the equation obtained in the classical theory, but where is the difference? The difference is the only assumption. Classical theory explained about the conductivity of conductors based on the assumption that electrons are moving like a gas molecule, but the quantum theory explained about the conductivity of conductors based on the assumption that not all electrons are moving like gas molecules, only the electrons which are nearer to the Fermi surface, they will only participate in the conductivity, remaining electrons are not participating. This is a main difference between the classical theory and quantum theory. Based on this assumption that quantum theory successfully explained about the specific heat of metals, quantum theory successfully explained about the electrical conductivity as well as thermal conductivity of metals or conductors based on assumption that if electrons are nearer to Fermi surface, they will cause the reason of conductivity. This is completely called as quantum free electron theory, which is discussed by the Sommerfeld. Thank you for watching. For getting regular updates from my channel, click on the bell icon. You will get the notification and you will get go for the next one. Thank you for watching.